In this video, we're going to be using some basic algebra to prove that 1 is equal to 2. Well, maybe. First of all, let's define two variables, p and q, and we'll say that the value of p is equal to the value of q. Now that gives us the equation p is equal to q. Now let's take that equation and multiply both sides by p. So p times p is equal to p times q. Or simply, pp is equal to pq. But wait, pp just means p times p, or p squared. So we can say p squared is equal to p times q, or pq. And now let's subtract q squared from each side of that equation. So we've done the same thing to both sides of that equation, so it's still an equation, and p squared minus q squared is equal to pq minus q squared. Now when we've got a square thing minus another square thing, we call this the difference of two squares. And we can factorise that expression like this. P squared minus q squared is equal to p minus q times p plus q. So let's just check that. Positive p times positive p is positive p squared. Positive p times positive q is positive pq. Negative q times positive p is negative qp. And negative q times positive q is negative q squared. Now pq means p times q, and qp means q times p. But multiplication is commutative, and that means that it doesn't matter which order you multiply things together in. So p times q gives you the same result as q times p. And that means that I can re-express qp as pq. So our expression now reads p squared plus pq minus q squared. And pq, take away pq, is nothing. And in multiplying out p minus q times p plus q, I've proved that these two things are in fact equal. And that means I can write out the left-hand side of my equation like this. So I've now got p minus q times p plus q is equal to pq minus q squared. So I've factorised the left-hand side of our equation, but over on the right we can see that both terms have a common factor of q as well, so I could factorise that side too. So we've now got p minus q times p plus q is equal to q times p minus q. Now you'll notice we've got p minus q on both sides of our equation, so if I divide both sides by p minus q, I'll have p minus q in the numerator and the denominator on both sides, and I can cancel them out. P minus q divided by p minus q on the left hand side is 1, and likewise on the right hand side. So on the left hand side I've got 1 times p plus q over 1, which is just p plus q, and on the right hand side I've got q times 1 over 1, which is just q. And that leaves me with p plus q is equal to q. Now remember, back at the beginning we said that p was equal to q, and that means that I can replace p with q in my equation, which gives us q plus q is equal to q. Well, q plus q is just equal to 2q, so now 2q is equal to q. Now I can divide both sides by q, and on the left q divided by q is 1, and on the right likewise q divided by q is 1. Now that leaves us with 2 times 1 over 1 on the left hand side, which is just 2, and 1 divided by 1 on the right hand side, which is just 1. So there we have it, 2 is equal to 1. Or indeed, 1 is equal to 2. Well, there it is, we've broken maths. Not much point in carrying on. Okay, pause the video, have a look through line by line, and see if you can find any errors in our logic. Well, obviously 1 isn't equal to 2. If it was, I think we'd have heard it on the news by now. So let's go through our working out line by line and see if we can work out what's happened. Well, defining two variables, p and q, and letting them be equal, there's no problem with that. And it's perfectly okay to multiply both sides of our equation by the same thing, p. And yes, p squared is equal to p times p, so that's correct. Also, subtracting the same thing from each side of our equation does keep it equal, so that's alright too. Now, we looked at the difference of two squares factorisation in some detail earlier on, and that's perfectly okay as well. And factorising out the common factor of q on the right hand side, that's perfectly okay. Now, in moving from step 6 to step 7, we divided both sides of the equation by p minus q. Well, this might normally be okay, but we did say right at the beginning that p was equal to q. So p minus q is equal to something minus itself, that's 0. So we're dividing both sides of our equation by 0. Now that is a problem. For example, what's 1 divided by 0? Well, it doesn't matter how many times you add 0 to itself, you're never going to reach 1. Anything divided by 0 is undefined. So when you divide things in equations, you really must check that what you're dividing by is not equal to 0. Okay, let's look at it a slightly different way. In line 6, we've got p minus q times p plus q, but p minus q is 0. So the left-hand side really means 0 times p plus q. And p minus q is 0 on the right-hand side as well, so that becomes q times 0. So we're saying that 0 times something is equal to something times 0. Well, 0 times something is 0, and something times 0 is 0. So here we're saying that 0 is equal to 0. And yep, that is true. But that doesn't mean that the things that we're multiplying by 0 are also equal. So in moving from line 6 to 7, we don't know that p plus q is equal to q. We only know that 0 times p plus q is equal to 0 times q. And that means that all of this is wrong. We haven't proved that 1 is equal to 2, we've proved that 0 times 1 is equal to 0 times 2. Hooray! It looks like the world of maths is safe after all.